In this session, we are going to talk about 11th Physics, chapter number 4, Laws of Motion, part 7. First point is, rotational analog of force or moment of force or torque in animation is explained as
torque or moment of force on a particle. The moment of a force or torque due to a force about a point acting on a rigid body provides the turning or twisting effect of force that causes rotation about a fixed point or a fixed line or axis. The magnitude of the torque about a point or axis is expressed by the product of the magnitude of the applied force and perpendicular distance of the point of application or line of action of the force from the point about which the force is free to rotate or the axis of rotation of the rigid body.
Hello, today we will speak about the moment of a force or the torque. Consider a door that has the ability to rotate about a fixed axis delta passing through its hinges. If we try to push the door, not any force can cause its rotation. If the line of action of the force is parallel to the axis of rotation or passing through it, then the force has no ability to cause rotation. So how can we open or close the door? A force has tendency to rotate an object about an axis if its line of action and the axis are neither parallel nor intersecting. The moment of a force is a physical quantity that measures the tendency of the force to rotate an object about a given axis. Consider a wrench that has the ability to rotate about a fixed axis passing through its pivot point and perpendicular to the plane of the screen. A force of magnitude 17 newtons is applied at the end of the wrench at an angle 37 degrees with the axis of the wrench and 25 centimeters away from the pivot point. Different forces can rotate the wrench either clockwise, like the direction of rotation of the arms of the clock, or anti-clockwise. The force F can rotate the wrench anti-clockwise, so let's choose the positive sense of rotation to be anti-clockwise. So let's calculate the moment of a force. The moment of a force about fixed axis delta is equal plus or minus F times d, where F is the magnitude of the force and d is the perpendicular distance between the line of action of the force and the axis of rotation. We still have to find the distance d. We extend the line of action of the force, then we put one of the sides of the set square on the line of action of the force, and we move the set square until we reach the pivot point. The other side of the set square is the distance d, where d is the perpendicular distance between the line of action of the force and the axis of rotation passing through the pivot point. The moment is positive when the force can rotate the object in the positive sense of rotation, and it is negative when the force can rotate the object in the negative sense of rotation. The force is expressed in newtons and the distance is expressed in meters, so the moment is expressed in Newton times meters. Consider this triangle. In this triangle, sine 37 equals opposite over the hypotenuse equals d over 25. So d is equal to 25 times sine 37. Inserting the values of d and f in the equation of moment, we get that the moment equals 2.55 Newton times meters. And this is everything for now.
now rotational analog of a force or moment of force or torque. While opening a door fixed to a frame on hinges, we apply the force away from the hinges and perpendicular to the door to open it with ease. In this case, we are interested in achieving some angular displacement for the door. If the force is applied near the hinges, ordinarily parallel to the door, it is very difficult to open the door. Similarly, if the door is heavier, made up of iron instead of wood or plastic, we need to apply proportionally larger force for the same angular displacement. It shows that rotational ability of a force that only depends upon the mass that is greater force for greater mass, but also upon the point of application of the force, the point should be as away as possible from the axis of rotation, and the angle between direction of the force and the line joining the axis of rotation with the point of application, that is, effect is maximum if this angle is 90 degree. Take into account all these factors, the quantity of moment of force or torque is defined as the rotational analog of a force. As rotation refers to direction, sense of rotation, torque must be vector quantity in its mathematical form. This is the diagram for illustration of moment of force with object and axis of rotation, which is as shown in figure 4.6a. This is the figure 4.6b, where the top view for moment of force vector F in anticlockwise rotation with vector F and vector R in the plane of paper. Similarly, figure 4.6c, top view of moment of force vector F in clockwise rotation, vector F and vector R in the plane of paper. Torque or moment of force is given by tau is equal to capital F into small r 4.17, where F is applied force and the position vector of the point of application of the force from the axis of rotation as shown in the figures 4.6b and 4.6. The directions are inward. Figure 4.6a is a 3D drawing indicating the laminar, that is plane or two-dimensional object rotating about a fixed axis of rotation AOB, the axis being perpendicular to the object and passing through it. Figure 4.6b indicates top view of the object when the rotation is in anticlockwise direction, and figure 4.6c shows the view from the top if rotation is in the clockwise direction. In fact, figure 4.6b and 4.6c are drawn in such a way that the applied force F and position vector of the point of the application of the force are in the plane of these figures. Direction of the torque is always perpendicular to the plane containing the vectors, and F and can be obtained from the rule of cross product or by using the right hand thumb rule. In figure 4.6b, it is a perpendicular to the plane of paper. Figure in this one case, perpendicular to the body and outwards, that is coming out of the paper, while in the figure 4.6c it is inwards, that is going into the paper. In order to indicate the directions which are not in the plane of the figure, we use a special convention O for perpendicular to the plane of figure and outwards for perpendicular to the plane of figure and inwards. This convention depends upon traditional arrow shown in figure 4.7a. Convention of pictorial representation of vectors as shown in A, acting in direction perpendicular to the plane of paper, coming out of paper, C, going in the paper, and D, perpendicular to the plane of paper, which is as shown in these four figures as A, B, C, D. Consider yourself looking towards the figure from the top. If this arrow approaches you, the tip of arrow will be prominently seen. Hence, circle with a dot in it. Figure 4.7b refers to perpendicular and outwards or towards you when you are leaving an arrow, that is If an arrow is going away from you, the feathers like a cross will be seen. Hence, a circle with a cross, figure 4.6a, indicates perpendicular and inwards or away from you. Circle with cross and dot indicates a line perpendicular to the plane of paper, which is shown in 4.6d. Magnitude of torque, tau is equal to Rf sin theta, as equation 4.18, where theta is the smaller angle between the one directions of R and F. Next point is consequences. First, if R or F is greater, the torque, hence rotational effect, is greater. Thus, it is recommended to apply the force away from the hinges. Second, consequences of moment of force. If theta is equal to 90 degree, tau is equal to R into F, thus the force should be applied along normal direction for AG rotation. Third consequences, if theta is equal to 0 degree or 180 degree, torque is minimum, which is equal to 0. Thus, if the force is applied parallel or anti-parallel to there is no rotation. For moment of force depends not only on the magnitude and direction of the force, but also on the point where the force acts with respect to the axis of rotation. Same force can have different torques as per its point of application. Thank you. H, I and J, A, B, C, D, E, F, G, H, I, J, A, B, C, A, B, C, D, E, F, A, B, C, A, B, C, D, E, F, G, H, A, B, C, D, E, F, G, H, दोन पुढच्या पाठ 3